welcome to the first Crossvale tech talk. Since I proposed the idea, it is fair that I start with them to encourage more people to participate. Well, let's start with it. The deep web, probably something most of you have heard about. You know that place on the internet where there are hackers, criminals, drugs, weapons, and of course I can forget about aliens because why not? But jokes aside, let me show you a famous image about this topic, the famous iceberg of the internet. Here, as you can see, we have what it is called the surface web with our typical websites and all things. And then we have the deep web with most of the content of the internet. Actually, this content is visited by you really often because when we talk about deep web, we are referring to all things that do not appear in search engines like Google, Bing, or whatever. So no weird thing happening here because we have Drive, we have the Gmail inbox, that kind of stuff. And you could say, well, what about the dark web that is at the bottom? All the alien stuff is there, right? Well, yeah, there are a lot of shadowy things in what it is called the dark web. But in reality, when people talk about the dark web, they are referring to the Tor network. And that is what we are going to talk about. Actually, the Tor original title is this, but the deep web sounds better. So yeah, that's why I didn't call like the call like that. So Tor, an onion routing implementation. What the hell is onion routing? So let's see how this magic works. Okay, let's imagine the next scenario. I want to send a message to a certain destination, but I want to remain anonymous. So for that, I choose 3 nodes. Every node has a pair of keys, private and public keys. And now I'm going to take my message and I will encrypt it 3 times. 3 layers of encryption, each layer with one of the keys. Using the public key of the nodes that I want to use as proxies, basically. The order of the encryption is like this. First, the blue key from the last node, then the second node key, that is the red one, and then the yellow key. So in reverse order, basically. So now we send the message to the first node. The first node will receive the message and will decrypt the outer layer of encryption. Now it sends the message to the second node. The node do the same thing with the red key, and now the last node can decrypt the message and get the original message we sent. This message can be now sent to the destination, and the response will do the same procedure, but in reverse. Some of you may have noticed, but the last part of the communication is not encrypted by Tor. So if you're using an insecure protocol like HTTP, FTP, whatever, if someone is looking for the traffic in there, they can read the information. So the protocol is important here. This is because in that part of the communication, we are leaving the Tor network. So because we have to reach the normal server in the surface web. There are a special kind of services that lives inside the Tor network and does not have this problem. More about that later. But yeah, for now, the encryption in the protocol used, like HTTPS, is something we need. So well, for this is because the Tor logo has an onion and it's called onion routing because of layers. So now, let me explain some concepts I need you to understand before going on. Tor circuits, they are formed by Tor using 3 nodes or relays. The client will use this chain of proxies to connect to the destination. Basically, what we just saw before, but with a cool name, okay? Tor circuits need to be refreshed every now and then to make sure the client remains anonymous. So the protocol considers a circuit as dirty once it once it is used. And after about 10 minutes, if the circuit is not in use, the circuit is refreshed and a new nodes are selected. So a new IP address is used effectively. Then Tor cells. The information is sent across the Tor network in units called cells. These cells are about 512 bytes each. Basically, this helps the network to avoid network analysis procedures from uncovering users since all the packages looks the same. So it's like a really crowded street. So it's hard to find anyone there. Okay. Now let's talk about what type of nodes there are in the Tor network. First, war and middle relays. These are the most common types, and in essence, they are the same, but the main difference is that the war nodes are trusted by the network. They have like a certain requirements for a middle relay to be considered a war node. A war node is basically the first node of the chain, and a middle relay, the middle relay is the second one. Yeah. It is important to say that these nodes IP addresses are published by Tor, because when the clients build the circuit, it needs to know what IP addresses are available. So this could add your node IP to some blacklist because it's part of the Tor network, and some administrators doesn't like the network. So yeah, just a warning there. About exit relays, these are the last part of the secrets or the chain, and as the above nodes, the IP addresses are published. Hosting this kind of node is not illegal, but if someone used the Tor network for nefarious things, probably your IP address will be in the victim logs, so they will search for you. That is why the Tor documentation includes tips about how to defend yourself against legal problems like, attacks and whatever. The last one, the bridge nodes. These nodes are not published by Tor and need to be manually entered in the Tor browser configuration to be able to use them. They are used mainly by people living in countries with strict regimes, where the access to the information is very limited, and obviously access to normal Tor nodes or VPNs is forbidden, like China, Russia, Once we know a bit more about Tor, let's see what kind of vulnerabilities the Tor network could have. Okay, first, the obvious one, traffic analysis. We talked about it a bit before. Someone could study the traffic that goes into the Tor network and the traffic that goes out of it and try to correlate it. The problem with this method is that if the network has a lot of users, this analysis is not possible. It's really, really difficult. That is why it is important for the Tor network to have active users every time. Actually, the Tor network was created by the US Navy to protect its agents, but since if only the Navy agents were using it, it was useless. So they just released it to the public. So nefarious relays. This is a method that is used by, for example, the FBI that consists on running a lot of Tor nodes, expecting that in some moment, a certain user Tor circuit is formed using a war node and an exit node controlled by them. That way, it is easier to defeat Tor protections. Lastly, the 0 days vulnerabilities. Obviously, like any program out there, Tor has and will have 0 days vulnerabilities that can be used to de-anonymize users easily. Okay, so what about the Tor secret services, the dark websites, okay? How they work? Okay, the idea is to have a service that can be reached by users, but keeping both the service and the users anonymous. There are a lot of stuff going on in this slide, I know. But before starting it, I want to point out that the lines that join computers are Tor circuits. So if you see two computers connected by this kind of lines, that means that there are 3 hops between them. So as you will see, there are a lot of hops here. Imagine now that we want to host the Crossvale website in the Tor network, okay? So we install all the necessary stuff in the server and set up a hidden service following the Tor documentation. In this case, a web page. When the hidden service is created, it will generate a pair of keys, a public and a private key. And also it will select 3 random nodes in the Tor network that will now be introduction points to our service. Lastly, it will create an onion address that is basically a hash derived from the public key. Okay, it's like a code. With all this information, the server will create what it is called a hidden service descriptor that will be stored in the Tor network distributed database and then the server will establish a connection to the 3 introduction points. This descriptor works like a DNS record. So it's searched using the onion address generated before, and therefore it is really difficult to index all the hidden services running in the network because they are hashes, they are complex combinations of numbers and letters. So yeah, it's pretty hard to index all of them. There are some search engines projects, but most of them, most of the sites that are already indexed are provided by users. So yeah, it's pretty hard. Oops. Okay, now we have our server running. So let's see how a client can connect to it. First, the client will connect to a random node in the network that will be called the rendezvous point. In this case, the Tor circuit to the rendezvous point is only formed by 2 nodes, but more about that later. The client sends to the rendezvous point a secret, okay, a cookie, a secret, and the onion address of the service that we are connecting to. Now, the rendezvous point will get the hidden service descriptor and choose one of the introduction points we selected earlier, sending to it both the secret and also its sound IP address, because remember that we are using Tor circuits. So to tell the introduction point where to meet later, it needs to send its own IP address. The introduction point now sends all this information to the server, and the server can now decide if it wants to let the client access or not, based on the secret. In this case, let's say it accepts the connection. So the server now connects to the rendezvous point, sending the secret, and the rendezvous point can now validate if the secrets match with the client's secrets or not. If the secrets match, the rendezvous point just link the connections and start acting like the third node of the chain for the client. Because remember, the client was using just 2 nodes for the Tor circuit. And now the connection is established, and they can start. The client can now access the web page. I know that probably you have like a lot of questions about this process because I know it's complex, but we can check them out at the end. Okay. Just an extra thing: some services don't really need to be anonymous because everyone knows where they are. This is the case for Facebook that has a site in the Tor network. Since the normal connection to hidden services is very slow because there are like 6 hops in total between server and client, there is something called Heredia. Just like this, the server can connect directly to the rendezvous point, so only 3 hops in total. So it's pretty faster. And here I let you some resources. You can check for more information. I really recommend the 3 computer file channel videos. They explain all this incredibly well, and the channel itself is awesome too. Well, basically that was all. Thanks for listening. Hope you learned something today, and we can now start with the question round. Yeah.
Thank you very much. That was brilliant. Thanks a lot, guys.
Thanks.
From the tech team, are there any questions? And I know I'm finding it fascinating. This I've got a fairly important one in a second. But any questions, guys? First, you want to all unmute yourselves?
Angel, have you searched for applications of the Tor network outside of the very well-known use cases that are out there?
You mean like use it for SSH or whatever?
Yes.
Yeah, everything that works over TCP can be used as a hidden service. So you can host FTP, SSH, web page, whatever that works over TCP is allowed.
Could I just ask, just from a more simplistic view, how, sort of on everyone that's joining this call today, how many people are currently or have already used the Tor browser? And in one way, two sides to it. One, through work, because you mentioned yourself already, Angel, that we talk about the surface web, but all we're looking at underneath the iceberg is just addresses that are not publicly available by Google search engines and things like this. It's completely addressable. And then there's potentially a very small area, let's call it the dark web, the dodgy area, whatever you want to call it. But to browse all of this, are we needing to use Tor browsers? And if so, are we using it in business today?
To browse the dark web, you mean?
Yes.
You don't have to use Tor browser. Tor browser just make all this process automatically of creating the relays, connecting to the different nodes, whatever. But you could actually set up your computer to use the Tor network, for example, and use Chrome directly. But obviously, you need to do a lot of setup in order to do this.
Yeah, very much so. So back to the just other people on this call. There's a couple of people on the consulting as well. Has anybody had to use this route for the kind of work we currently do today? I mean, there are some projects that we're on that are sometimes sensitive, and we work with sensitive companies. So does anyone having to go this route anyway?